Welcome, viewers, to the fourth segment of the third lecture for the online series of lectures for the course of Algebraic Topology 2. So, in the previous segment, towards the end, we were discussing um, um, chain complexes and chain map between two chain complexes. Okay, there. So we have seen that. So the first sequence is one chain complex. The second sequence here is another chain complex, and the chain map uh, between these two chain complexes is a family of homomorphisms that we have written down here, so that these homomorphisms uh, satisfy this equality. So in other words, we say here is that the boundary map of the chain complexes are preserved under such homomorphism. Okay, so by this example, we see how we construct homomorphism between two sequences, which is the homomorphism is actually a family, right? Okay. Uh, Now, an important definition of split exact sequence. Let me define it now. Definition. Consider the following short exact sequence zero to A1 to A2 to A3 to 0, okay, where phi is the homomorphism from A1 to A2 and psi is the homomorphism from A2 to A3. This sequence is said to split if the group phi of A1, right? Phi is the homomorphism between these two abelian groups. So the homomorphic image of A1 under phi is a subgroup of A2, right? And the group phi of A1 is a direct summand in A2. Okay, what does it mean? It means that A2 is the internal direct sum of this component phi of A1 and some other subgroup B of A2. Okay. Why do we call it an internal direct sum? Because we know what A2 is, we know the structure of A2, and we are decomposing A2 into the direct sum of these two pieces, phi of A1 and B. Okay, so the structure of the resulting object A2 is known a priori. That's why we call it internal direct sum. Okay, there is an equivalent formulation of split exact sequence we will see in a moment, which requires the notion of external direct sum, for which we don't know the resulting structure a priori. We don't require it. Okay, we just need the concept of the two pieces only. But here we have the resulting object a priori, which is A2, and we know we decompose it into two pieces. One is phi of A1 and the other one is B. Of course, B is not unique, okay? But this is what we mean by internal direct sum of two pieces. Okay. Uh, so so what we have written down here can be expressed by means of the following exact sequence. We express this fact with the following exact sequence. 0 goes to A1, A1 goes to phi of A1, direct sum B, and this thing goes to A3 to 0. So we have done nothing. We just have replaced A2 with this expression. Okay. So here A2 is equal to phi of A1 internal direct sum B. Okay. This is internal direct sum, or internal direct sum. Okay, so now there is an equivalent formulation of split exact sequence using external direct sum. Let me do it now. Let me give it to you. This equivalent formulation. An equivalent formulation using external direct sum is given as follows. 0 to A1 to A2 to A3 to A0. Okay, so phi psi, we are given this exact sequence, right? And it is said to split if we have this part of the diagram as well. 0 to A1, A1 to A1, direct sum A3 and A3 and 0 here. This is the canonical projection onto the second factor here, okay, this pi. So this is a pair here, and via this map, this pair is projected onto its second component here, and this is the canonical inclusion of A1 into A1 direct sum A3. Okay, so well, here we don't know about, or we are not concerned with the structure of the resulting object A1 direct sum A3. Okay, right? I'm not writing here A2 as A1 plus A3, but there is a map theta that relates A2 with A1 plus A3. Okay, and this is a map which is an equality. This is also a map which is an equality. Okay, this sum is called external direct sum. External direct sum. So how do we, so here I is the inclusion map, is the inclusion map, and pi is the projection onto the second factor. So let me write it as canonical projection. Canonical projection onto the second factor. All right, so how do you define this map theta? The map theta from A2 to the external direct sum of A1 and A3 is defined as for a given A and here in A2, theta of A is supposed to be a pair, right? Here. So theta of A is in A1 external direct sum A3, right? So theta of A is a pair whose first component is in A1 and the second component is in A3. So theta of A should be a pair whose first component is theta A1 and the second component is theta of A2. Okay, and theta of A1 is defined as the pre-image of A under phi. So A is here, right? A is here, and phi is a homomorphism. Remember, phi inverse does not mean that phi is invertible. It's the notation of the pre-image. So I take the pre-image of A under phi, which will be here. Okay, so the first component of theta of A is defined as the pre-image of A under phi, and the second component is defined as the second component is supposed to be in A3, and that is defined as psi of A. So A is here and its image will be in A3. That is the second component of theta of A. So this is how we define this map theta. With the help of this map theta, by means of external direct sum, we can define split exact sequence. So when this diagram commutes, we say that the sequence that we started with here is a split exact sequence, or the exact sequence that we started with is said to split. All right. Okay, that's good. So this is the end of the third lecture. Okay, so now we are all set. So so in the beginning of the fourth lecture, we will discuss some results concerning this this exact sequence business that we have developed in this last two segments of the third lecture, and then see how they connect to the homology theory that we have been studying. Thank you for attending the third lecture.